Welcome to our decentralized science panel, or how Web3 enables science. First of all, why don't we start with some introductions? Who you are, what you do, and who you work for.
Sure, thank you. Hi everyone, I'm Eleanor Davis, and I'm Chief of Operations at LabDAO. And so what is LabDAO? LabDAO is basically providing a research institution in order for scientists to do their research, access tools entirely online, and just basically making it easier for scientists to do their work, get funding, get tools, etc.
Hi, good morning, everybody. Thank you so much for having us here today to chat about DeSci. If you haven't heard of it, we'll hopefully be going into more details soon. My name is Shadi Eldamadi. I'm the founder of OpSci, or the Open Science DAO, and also the co-founder of Holonym, which is working on zero-knowledge proofs of off-chain claims on-chain.
Yeah, hi everyone. So I'm Martin Carlson, co-founder and CEO at Lateral.io, and we build tools to help with coordination and funding of research. And yeah, very excited to talk about the opportunities DeSci offers to really impact the planet. So this is one of the most exciting panels, just to say that.
Hi everybody, my name is Andre Taquadera. I'm the co-founder and chief executive of Lemon Protocol. And we're in essence applying tools and DAOs to allow patients and scientists and others to collaborate and tackle unmet needs in patient communities. And yeah, we'll talk in a bit more detail on that shortly.
And I'm Laura Modiano. I used to be head of healthcare and life science startups in EMEA for Amazon Web Services, and I work with VCs and founders. And I have to say, just in prep for this panel, I've learned more about DeSci and generally more from the people here than I have in a very long time. So I'm very excited for this conversation. Thank you. I'm going to start with Eroom's law. So everyone here, I assume, knows what Moore's law is. So a play on that is that currently, Eroom's law states that drug discovery is both taking longer and, is there background noise? And costing more. It's becoming more expensive, and DeSci is the answer to that. So let's start with what is DeSci and how it is playing in the ecosystem to help with incentivization, cost, and money shifting in different people across the ecosystem, and what the opportunities are created in the process. So why don't we start with you, Eleanor?
Cool, thank you. So what is DeSci? DeSci basically dovetails the open science movement, whereas the scientific research is open source, but you can also write on top of that. It's transparent, it's on the blockchain, and as far as citations are concerned, you can also see who has contributed, but also how much a user has contributed owing to tokenomics. There's also a lot more transparency. It's a lot easier to gain access to funding. So scientists spend about half of their time getting grants funding, which actually isn't the basis of what their work is. With DeSci, it basically opens up the access to funding. So you have grants, for instance, such as Gitcoin. There's also Optimism, Polygon, and others. And it basically just allows scientists who are working on something that may not be so novel, may not be so attractive for large research publications to actually pursue this project. And it's decentralized. It enables scientists from all over the world to come together. So you're also leveraging the wisdom of the crowds in order to do something that's potentially very impactful for human longevity. So, yeah.
Yeah, I think that's a great overall summary of DeSci. So I think, when we talk about DeSci, there's a bit of a kind of catchy phrase, right? Like you think DeFi, DeSci, people start thinking about decentralization and trying to apply the same templates from Web3 onto a bunch of scientists coordinating on the internet. I think there's a little bit of hype behind that, but also a little bit of truth, right? So if we kind of zoom back out and look at the history of open science practice and why it came about and where it came from, we'll see that there's been this increasing momentum or trend over the past 20, 25 years where software and scientific protocols or scientific methods have been converging, right? So things that could be automated, things that have traditionally lent themselves to digitization and automation that's been happening on an accelerating trend. You know, we're seeing that specifically, I think, in bioinformatics, physics, really, and geospatial sciences have really, planetary sciences have pushed the fore on that. And now other fields like neuroscience and computational genomics and so on and so forth are kind of moving along these lines. So when we're thinking of software kind of merging with science, what do we mean specifically? Well, that means that the actual protocols, the data, the people, they're all going to have some sort of digital footprint or identifier or correspondence that allows them to interact through these web applications. So the definition I like to put forward for decentralized science is one of web-native scientists that are using the internet to coordinate and execute their full science stack, from coming up with their ideas to figure out what they want to apply for grants for, to sourcing the materials and resources they need to execute the research, and finally circulating that research, the results of it for secondary kind of, you know, for sharing and publication. So yeah, maybe I'll leave it there and pass the mic.
Great. I'm actually going to follow up this with a question for you, Martin, which is, obviously I just mentioned drug discovery, and a lot of people think of DeSci as a very biotech-specific solution. So can you talk to us about, outside of biotech, outside of the drug discovery continuum, how you see other applications of DeSci in other industries where you think it would be relevant?
Yeah, absolutely. So I think DeSci is really, the promise of it is that it can go towards solving all the fundamental problems we have as a society in terms of the scientific elements that need to be coordinated. And one of the stories I like to tell, which is quite a fun one, is essentially that a great example that is currently underway is within marine ecosystem conservation, and it's called New Atlantis. And essentially, it threads the narrative from medicine and analysis that is current breakthroughs in analyzing our gut microbiome to cure diseases, through to how we can get a better, accurate view of marine ecosystems and how we can influence that to heal the planet. And so you basically, the reason I like that story is because it speaks to the interlinked concept of science and how learnings from one field can go across to the other. And for those that you are more on the DeFi side of things, the interesting element of this is that in the marine ecosystem world, essentially what they're going to be doing is mapping the DNA there in such a way that you can predict the effect that you have by impacting that ecosystem, and attaching that to new funding mechanisms so that you essentially have a new way to fund the successful cultivation of marine ecosystems, and actually use that to capture CO2. So there's an entire narrative of how whales help us to capture CO2 that then you can fund by these new DeFi mechanisms that then fund research that's fundamentally making the world better. And all of these links come together. So that's really how it spreads across different elements.
Fantastic. Thank you. I had another question in mind, but I'm actually going to go straight to Andre, just because obviously some of the examples and the topics we're discussing now is a lot of the B2B, creating the ecosystem, how scientists work together, how the industry comes together. However, a big part of science, especially when we talk about the impact it has on patients on the biotech side, is how do patients end up coming into this process and participating anew? And I know you're very big in trying to change that in the industry right now, so.
Yeah, definitely. I think DeSci and just Web3 in general just lowers the barrier to entry, which doesn't currently exist within the industry and pharma. So it gives them more opportunities to participate in research. And when that's done, typically research translates better to the market, because ultimately patients are the most incentivized to cure disease. And I think when you factor that in a more systematic manner, we're trying to do that through DAOs. They have the opportunity to share their perspective in terms of expressing unmet needs within those patient communities. They can also collaborate with scientists within the DeSci ecosystem to basically work on proposals to tackle those unmet needs, and also fund them through DAO treasuries, because sometimes the incentives between industry and pharma doesn't always align with the patients. And I think DAOs provide the opportunity to allow that to happen and change that dynamic. And also the ability to kind of share their data in a privacy-preserving way as well. Because the industry has a bit of a problem with data quality for patients. So I think if you rely on a community of patients to aggregate their data from a variety of sources, whether it be wearables, the hospital data, etc., you'll have much better quality data when the patients are properly engaged. So yeah, I think in essence it just opens the market to patients and scientists who wouldn't get funding for what they really want to study. And I think that could be very powerful when we can empower the actual creators of products and science through these tools.
Fantastic.
Yeah.
Thank you. So I'm going to go back to the two of you. So the big argument and benefit of DeSci is that it allows for a shift of how money flows in the ecosystem. It goes from a centralized approach to big pharma, publishers, to decentralized, and it's going to researchers, reviewers across the ecosystem. Everyone can benefit, so and be empowered. So in being a contributor in the system and supporting this underfunded innovation, what are the examples of how this works in practice? So, and actually I'd like all of you to address that, because all of your companies are fixing this problem from a different perspective, and that will allow us to understand how your different organizations are playing into the ecosystem.
Great, I'll start. So how do we manage the flowing of funding into the ecosystem? So LabDAO is raising funds from VC, also from Web3 funds. So how is this managed? Well, basically, in terms of coordinating a DAO, in order to manage DAO health, it's kind of best to have a incentivized core team that works on maintaining the operations of the ecosystem. And then there's the stewards, and then there's the bounties, where scientists can basically work on projects, can also earn lab tokens, and basically, in short, so this kind of creates a network effect as the value of the ecosystem accrues. And this also builds into the lab token. Not only is the token a point where value is accruing, but also the tools that we're building. So first off, we're kind of testing these out in the DeSci ecosystem, seem to be working, but also wondering how can we scale this into a marketable product that we can sell to universities, companies that can also interact within the DeSci ecosystem, and then basically creating a tool that is generating revenue, cash flow, and also providing returns on the initial funding. So I guess that's one way of interpreting your question. Shadi, it'd be good to hear your thoughts.
So that's so I think it's really helpful to have a mental model in place or an example when thinking about what are the major bottlenecks for just societal progress, right? So I'm going to go out there a little bit on the limb and say that scientific innovation drives over the long term overall GDP growth, overall commercial market growth, overall creation of new markets. And so we can maybe drill that down into that a little bit more and think about where does this kind of value creation comes from. Typically in the past, it's come from basic science research, right, which has maybe 20, 25, 30-year time horizon to ROIs, which is then turned into applied research and then so on and so forth, drug development, materials development, so on and so forth. So if we kind of go back to that origin point, there is this centralization, right? So taxpayer funding comes in, and then we have to fund things like the life cycle of a fruit fly egg, right? Or maybe the composition of limulus blood, right? In the horseshoe crab. Things that would go on to create multi-billion-dollar markets down the line. But nobody would have known that at first. So a funder has to, kind of sucks being a funder, right? They have to make this decision with incomplete information in a very vast parameter space, right? And they're going to have a bunch of trade-offs, right? There's probably a quadrilemma that I can think of at least in terms of the amount of funding that they have available, the type of scale that they want to see their impact at, the kind of impact that they're looking for, and then the overall kind of, I guess, like carrying capacity of experts, resources, and so forth necessary to push that forward. So, you can think of a great example, I think, with physics, right? So in physics, a funder can choose one of two things along a spectrum. They can choose to fund the James Webb telescope and put this one really big telescope up into space and point it at specific things and figure out very specific things that have kind of a confined scope. Or they could fund thousands of telescopes, right, like the Event Horizon Telescope, and create these synthetic apertures that allows us to measure all of the black holes in the galaxy, right, or in the universe, I'm sorry. And so I think the same kind of concept applies to thinking about how we could improve funding in a decentralized science sort of ecosystem, right, where now instead of having individual program officers and program directors that are sitting and collecting as much information as they can and sometimes making arbitrary politicized decisions, and thinking about how we could really deploy protocols that satisfy certain objective criteria for evaluation metrics for research outcomes, tying it to impact, tying it to the desired scale that we want to see effects at. And I think, for the very first time through Web3, we have tools that allow us to tie verifiable impact in the world, whether it's associated with the digital identifier of a researcher or a research object or derivative works of it, to the funding that might come in. So we can start thinking about dynamic sliding scales between the James Webb Telescope and the Event Horizon Telescope and being able to allocate funds more efficiently that way.
I think you can always trust a neuroscientist to give us a good mental model. So thank you.
You're welcome.
Martin, can I just ask you to put a bit more of a spin on sort of incentivization and how do you bring people in together to the process?
Yeah, absolutely. And building on Shadi's point, I think, so what we're effectively building with a group of partners is a decentralized graph where all the answers to these different problems can live and have a bottom-up effect, where those that contribute those answers then have full agency for their knowledge and then have a path to be rewarded when they contribute their solutions to that graph. And so this really puts into concrete terms what Shadi was saying, because you literally have a graph that is able to capture the complexity of all the global researchers that are working towards these solutions, and you can have different lenses to see what is the trade-off if we put funding here versus here, how does that impact the research over here, and there's a lot of different initiatives that are basically working to map science in this way, and the promise of Web3 is essentially that you have a neutral space where all these players can come together without the fear of one third party kind of taking control of everything. And so to the incentive point, what this graph gives you is a lot of new mechanisms where you can have retroactive rewards. So for example, you can start tracking contributions on the graph and be able to see, okay, further down the line, when the impact is made, who actually contributed to this. And so you have long-term rewards in that way to incentivize participation, but then you also have, as Eleanor was mentioning, short-term bounties to say, okay, there's a bottleneck in this research process, we want to put X amount of capital towards it, and then you attract research towards that. So you're literally creating the UX for coordinating these extremely complex problems in a way that all researchers can feel comfortable participating with because of all the privacy-preserving and immutable record capabilities of Web3.
Fantastic, thank you. I'm going to get to you, Andre, but I'm going to add one more layer of complexity to it, just because I know you're an expert on the topic. So obviously we're discussing about a paradigm shift in an industry that is very heavily regulated right now. So we could all discuss for hours whether we trust the FDA and EMA and NIH and how grants are being delivered, et cetera. So given both the paradigm shift on how money flows and how people are participating in the ecosystem, but also the trust and the necessity for a level of regulation, how do we ensure that continued trust in the outputs of science in this model exists, as well as what is the regulatory requirement and policy requirement that should or should not exist for this to continue to work and for people to continue to trust both in participating and in the outputs that are coming out?
Yeah, makes sense. Yes, I think trust is always massively helped by transparency, and also a way to make sure that that transparency in the process that led to the output is immutable and can be audited by the likes of the FDA and others. And also some things around ethics, like the IRB. It's very important to kind of get that ethical sign-off, because without that, you would have a lot of issues if your study is against the patient's interests.
Sorry, can I just, for the ones who are not scientists here,
oh, yeah.
IRB?
Sorry, Institutional Review Board, where they basically look at a study to see if it's ethical to the patients who are participating. So yeah, I think that's very key, and I think also, people in our space tend to overestimate the effectiveness of regulation and from the likes of the FDA. So over the past 100 years, there's been some measures put in place to improve the safety and efficacy of drugs, etc., which is obviously very noble, but the reality is the innovation in this space has slowed down massively. I think they estimated that 2.5 times more drugs could have been produced if those weren't in place. And also, if you look at the safety and efficacy and how that's materialized versus drugs which aren't authorized but are still used by patients and doctors, there's no clear improvement in safety and efficacy. So I think, and also that process, because it's more complex and takes time, it's very costly, and it kind of highs the barrier to entry when it comes to innovating. So I think DeSci can survive without regulation, because when you kind of empower patients who actually want to solve the problem with scientists who are working in an open and transparent way, that leads to much better outcomes compared to what the industry has done. Like 90% of research fails, and a lot of money's been going into that. But at the same time, if you want to work with regulators, etc., there needs to be a level of transparency. And also, what the regulator can do is implement policies which allow that community of creators, patients, and scientists to actually translate their innovations. And two examples I can think of. So the FDA released some policies around orphan drugs, so rare diseases, because pharma doesn't typically pay attention to rare diseases. So there's now incentives and regulation which gives rare disease drug developers and patients some incentives when it comes to tax credits, and also a faster time to market, but also exclusivity of the drug if it does reach the market. And there's also breakthrough therapy policy as well. So if you're able to produce a substantial breakthrough in a disease area, the FDA helps you there as well. So I think more of those type of policies that makes it easier for early innovators, which I think DeSci will be, would definitely help from the regulator standpoint. And I mentioned two, but it could be so much more.
I'll take it back to you, Eleanor. Can you talk to us about how the Web3 stack applies to DeSci specifically?
Sure. So I'll take LabDAO as the use case for Web3 stack. So what we do basically is, first off, helping scientists to safely manage their funds. So setting up a Gnosis safe and a MetaMask can be incredibly complicated for somebody who's completely new to the space. So that's something that we support on. There's the legal support as well. So what is the legal environment in Web3, especially DeSci? And it's so nascent, it's practically still being written. And I mean, we also don't know the answers to everything, but we have, we are making the best use of the information that we have. So for instance, how would you wrap a DAO? How would you legally wrap a DAO? And if you were to produce IP, how would you treat this from, say, a Series LLC into a commercial entity? How would you transfer funding into this commercial entity? How would a convertible note work in this instance? How does the tokenomics work in this instance? So that's support that we're providing there. There's also the access to the community. So that's the more decentralized part. Giving scientists access to get involved in these projects, building hype, getting scientists to work on these projects, providing bounties, providing tokens. There's also the grant support. So as I mentioned earlier, 50% of scientists' time spent writing grants. We can help with that. We can do that on Web3, with Web3 applications. We can do that outside of Web3 applications. So there's the Methuselah Fund, which is an example of this. And there's also the contribution certificates as well. In terms of the actual scientific research part, there's the compute infrastructure. So we've actually partnered with Protocol Labs, an application called BLOCKADE, which...
The Amazon Web Services person likes to
Yes.
hear that.
Sorry.
I like hearing
Oh,
that.
right.
Yeah.
Sorry, I didn't hear what you said. Yeah, BLOCKADE. And this basically enables scientists to run the compute on their laptop from anywhere in the world. So this is a petabyte of data for free. Applications you can run are, you you work on small molecule docking to RNA-seq, for example. And there's also the access to wet laboratories. So we partnered with Science Exchange, Chromatic, which basically gives scientists access to over 3,500 laboratories. So what LabDAO does is uses the fundamentals of Web3 in the DeSci application and also in the real world, but kind of packages them all together and curates a project and then is able to manage that. So it's kind of like an EF or Stripe Atlas, but for science.
Wonderful. So that'll be the last question I'll ask to the two of you, and then we'll have a quick fire round. So given the volatility in the crypto space, we've obviously talked a little bit about regulation, about bringing people in because we're using blockchain and crypto in order to get people involved in a new way of getting remuneration for their efforts. So how do we ensure the continued participation and trust to deliver on the vision and outcomes that DeSci is offering to the different participants in the ecosystem, from researchers, peer reviewers, grant providers, patients, etc.? Start with you, and then I'll go to you.
Start with me? Yeah.
But,
Okay. With Martin.
Starting here,
please.
but I mean,
Yeah, so I think it really comes, trust is the key word here. And I think what the, one anecdote that I think is worth telling, so scientists are by nature quite skeptical, which is quite a funny thing when you combine it with Web3 in general. And so I think what's great is that what you have emerging are these DeSci communities and DAOs that are bringing together extremely competent experts in the space. NIH directors, I've seen NIH directors of labs sign up to these DAOs, and it's just like the level of the intelligence coming into these groups is mind-blowing. So I think on the one hand, what you have are these smaller communities that then can introduce these tokenomics to be able to give better attribution, better reward mechanisms, and so on within their own communities. So this allows you to have more transparency of what's going on, and also disentangling it from some of the other elements of, let's say, the industry, and making it clear what parts of those concepts are being used here to the benefit of the researchers and the benefit of the community. So I think establishing that trust through that transparency, through those communities, and bringing on those experts to help communicate that is really helping to highlight the benefits while being conscious of the cons, and using the scientific skepticism in a healthy way on a constant basis, basically.
perfect, thank you.
Yeah, just to, I think, kind of, again, come back a little bit to regulations and how that's related to trust. So, a ton of the kind of reactionary regulations and breaches of, have occurred in response to breaches of trust, right? So if you ever had to go through like HIPAA training and learn the entire history of all the ways that scientists breached trust in the past because there was no protections in place, it's pretty sobering, actually. So, we can really drill down into that and identify one of the core issues is coordination, right? So coordination between all of the stakeholders that are involved within a scientific discovery. In biotech, it'll often include not only the people that are purchasing the drugs, but perhaps the patients, right? Like what Fleming Protocol is working on, linking patients into the flow there. So, I think when it comes to establishing trust, we're in a really good place in Web3 because we have very basic tools for building mechanisms of trust. And I think that begins first with testing that locally within our own communities, such as through governance, such as through incentive loops with flywheel effects of tokenomic design, but then extending that to in terms of bridges to the existing legacy infrastructure. And so that's a lot of where my work particularly is focused. So specifically being able to take off-chain facts. So like, for example, the legitimacy of a government ID or an academic credential, or perhaps of a scientific contribution that's come off a piece of instrumentation. And then putting that in a way in a public database where others can operate on top of that, make decisions, and write logical flows. I think really key to this also is the fact that privacy is something that we cannot ignore as part of the architecture or design patterns that we're seeking to put into deployment. So I do believe that zero-knowledge proofs are going to have, and different variations of zero-knowledge systems and circuit design are going to have a significant effect in how we really deploy and achieve these systems, whether it's putting genetic information on chain but in a sparse Merkle tree, right, where everyone's perhaps protected as like a tornado cache of genes, as an example, where you can prove certain things about genes, but not reveal any single individual's genes. And so these are problems that the open science movement is dealing with today and actually has no clear answers. Like, for example, in my specific scientific subfield, I work with large, massive neuroimaging data sets. And so these are going to be terabytes and terabytes of data with thousands of participants in them across multiple time points. And we go through great pains to remove the faces from these images and make them as identified as possible. But on the other side, we're also like predicting outcomes and individual traits, right? So at what point in a hyper-connected digital society does that come back to bite us in the butt? So I think it's really important to really root all of the core benefits that Web3 has in the DeSci stack and thinking about how to bridge existing legacy opportunities within the legacy system. And yeah, maybe I'll leave it there for now. But
I'll ask the question to the two of you as well, just specifically on the volatility of crypto and the trust that people have on the financial aspect of it now. And I will close with you because I know you have a lot to say.
Yeah, it's a tricky one. Because on the one hand, the kind of speculative element of crypto is bringing all of its capital into the space. But on the other hand, there's huge risks with that. And I think, as was mentioned, scientists are inherently skeptical, but so are patients, because the industry hasn't done what they could do by them. So they're inherently skeptical when a new solution is offered that doesn't actually benefit the patient. Sorry, what was the question again?
Volatility.
Volatility, yeah. So, I mean, quite simply, it kind of comes down to the tokenomics and kind of building incentives to kind of make people stake their tokens for longer and then rewarding that loyalty to the system. And there's also, in the kind of gaming part of Web3, I noticed, I can't remember the name of the company, but they have a federation DAO, and then they have sub-DAOs underneath it. And I think, in our case, we're thinking that if we were to have an overall DAO and then a diabetes DAO, epilepsy DAO, etc., you could then transfer the assets in the master treasury to those sub-DAOs, but maybe in more stable assets like USDC, for example.
I think that's a great transition for Eleanor. I could sense you smiling.
So basically, sure, there's a lot of volatility in the markets. However, in order to mitigate this, for instance, grants funding, a lot of them, for instance, Gitcoin, also LabDAO, Spark grants, are in USDC, so lower volatility. And also, it's important to note that the token for many DAOs is more of a governance token. It's less kind of day trading, that sort of thing. And science really is a public good. So the interests are different. There's a lot of skepticism in the crypto markets, but science, the communities of scientists and who can buy a token really depends on how you're going to interact with the community. And the token in LabDAO especially has kind of a baked-in mechanism where if you behave badly, then there's repercussions. There's no kind of governance right. Sure, the token will accrue in value, but there are also other ways of making money, creating value in the ecosystem. So there's also the network value, but there's also the projects that are in LabDAO. They may become something which is more entrepreneurial. They may become a new blockbuster drug. There's also the tools which will eventually, hopefully, become more centralized applications in the real world as well.
So that's a perfect segue for me. As we do have to close it, this is not going to be a quick fire round. What I will say for the people in the audience, obviously this is a very emerging part. Web3 as a whole is emerging, but DeSci in it is growing leaps and bounds. So you do have to be keeping up both with the science and Web3, and also what does that mean for the community, for the scientists? How does crypto come in? How do all the different pieces come together for it? Right now, it has great value for scientists and scientific community and patients, but we all need to be focused on what the commercial applications are. And what I like to say when I think and talk about it, especially to investors, is that a lot of traditional tech investors are leaving a lot of money on the table by not playing in the biotech space, by not investing in a very scientific, technical area where they don't have PhDs and they don't know how to do the tech and scientific due diligence. However, this is an avenue that will allow tech players to invest in the platform and the DAOs and the different parts of the ecosystem that they do understand, that then allow and does the due diligence for them to actually access the capital and the gains that the biotech space traditionally has not been open to them. So I'm very excited to see more of the traditional investors take part in our industry. We are all scientists here. And for more money to be made and all of you to take part in it. So thank you.